hello everybody. It's my pleasure to invite Alex de Sherbinin like a keynote speaker in our workshop. I'm happy that he will come from Columbia University in New York here. Alex, he's from Center for International Earth Science Information Network in Columbia University. Long name, I'm sorry, I don't remember the whole name of the institution. He's also Deputy Director of some NASA
data center, yes.
Yeah, century. So we are so happy that he's here. And at the beginning, we would like to introduce his topic by video, which was produced by World Bank, like a, let's say, introduction to the report, which was prepared by Alex and his colleagues from Columbia University and other institutions for World Bank. The name is Groundswell Report. So, thank you are here. We can start.
These numbers are projections at this stage, but could become a reality without concrete climate and development action. The report finds that if managed carefully, migration from vulnerable areas to more viable locations can bring new opportunities for people like Walde and Menora. We are already seeing individual success stories. Menora escaped her flood-stricken community in the Kurigram district in Bangladesh. She moved to the capital Dhaka to join a program that provides young rural women with life skills. Now, she's trained as a professional seamstress. She has a job offer in Dhaka that she plans to accept after graduation. Walde also plans to turn adversity into a chance to change the course of his life. The eighth of 16 children, he left his father's small farm in a drought-stricken part of Ethiopia and walked for days to the small city of Hawassa. Walde is now enrolled in Ethiopia's extensive urban safety net program. He receives a small salary for supervising street cleaners. Walde wants to study marketing at this polytechnic university, where he can attend classes for up to 3 years without paying tuition. Some communities are finding ways to deal with climate change that don't require migration. Javier and his brother chose to stay in their community in Oaxaca and expand their carpentry business. A sustainable forestry program has helped attract investors, enabling the community to adapt to a changing climate and build economic opportunities.
Un 100% de la población emigrará un 5 o 10%, y es un margen muy chico, pues, tanto a nivel bosque hay empleo, en los comercios hay empleo. No existe tanta necesidad de salir porque aquí en la comunidad no nomás hay carpinteros, hay albañiles, hay plomeros, comercios de tiendas, así que empleo hay de todo.
Menora and Walde and Javier's stories tell us that while internal climate migration is a growing reality in many countries, it doesn't have to be a crisis.
Thank you so much for coming out today for this lecture and for this opportunity to discuss climate migration. I hope it will be somewhat interactive. I was telling Robert before I came that a month ago my wife and I went to the New York Symphony Orchestra, and we went to see a performance by Prokofiev, Romeo and Juliet. Do you know what city the premiere of Romeo and Juliet was played in? Anyone here a classical music fan? It was here in Brno, so I thought this is a sign surely that I'm supposed to come to Brno and visit with you all. So anyway, this is a great pleasure and I'm really pleased to be here. I'd like to make this interactive, so if you want to stop me at any point or you don't understand what I'm saying, please just raise your hand so that I know and we'll answer your question. And then of course we'll have some time for discussion afterwards. So I'm at this center called CIESIN, which is part of Columbia University. CIESIN basically has a three-legged stool. So one part of it is dealing with cyber infrastructure. Another part is really about data management and data development in the area of global change. So we have this NASA data center. If you're in GIS and you're working with spatial data, you should check out the CDAC. So just Google NASA CDAC and you'll find us. And then we also do research on coupled human environment systems. So the type of work that I'm describing today combines elements of all three of these. So let's just talk a bit about definitions and sort of lay a foundation for my talks so that you'll all be able to follow along, hopefully. So one thing I want to make clear is even if we make the Paris targets, even if we achieve the Paris target of 1.5 degree Celsius rise, there will be fundamental changes to the Earth's climate system and fundamental changes to ecosystems, to productive systems, to everything, basically including forestry. I visited many forests over the last few days in the Czech Republic. There'll be major changes to these because of pest infestations, fire, and other changes. So here we have the graph showing on the low end RCP, representative concentration pathway 2.6. And this is the low end of the emission spectrum. And even if we obtain that low end, there'll be significant changes in temperature. If you look at the high end, though, it starts going up to 4 degrees, maybe as much as 5 or 6 degrees C, global average temperature increase. So people say, well, we see that kind of fluctuation on any given day. Why does it matter so much that we're up 2 degrees or 1 degree? We see that kind of change every day. The difference is the amount of energy, if you average that over the entire surface of the planet of the Earth, is dramatically greater. So it's much more energy, much more heating that occurs. And so days that used to be warm or hot in the summer will now be much more frequent. Days with extensive or high intensive rainfall will be much more frequent. And the consequences will include increased natural disasters, floods, droughts, the sorts of things we see in the newspaper almost every day today, we will see much more frequently, along with disruption of food production systems, natural ecosystems, and the global economy. In short, our planet will be transformed in fundamentally important ways that we cannot fully foresee. Let's lay another baseline or groundwork for our understanding together of what may happen in the future. And that has to do with migration theory. And there's some basic principles or theoretical foundations for what causes people to migrate and what kind of barriers they face. So on the right-hand side, you see this notion of origin or source areas and destination areas. And you have these mix of positive and negative factors that cause people to stay where they are in the origin area, often rural areas of developing countries or even places like the Czech Republic. And you have the mix of positive and negative things in the urban or destination areas. It's not always urban. It could be another rural area. And in between, you have these things called intervening obstacles. These are the things that prevent people from moving. They could be policies, they could be border frontier guards, it could be the cost. It may be in some locations around the world, even paying for a bus ticket to the capital is beyond the means of many rural peasants. So you have this mix of push and pull factors represented by the plus and minus signs here in the zeros. And if the push factors are significant, in other words, life becomes very difficult in the source area, and the pull factors such as education, better health care, jobs, economic success are greater in the destination area, then you'll tend to see people moving from one to the other. And this is the pattern we've seen really throughout human history. This is not a new phenomena. This theory, in fact, goes back to 1885. So some people were thinking about this even as far back as the 19th century. Then you have intervening obstacles. These are the peaks and valleys. You have the fact that migration tends to increase over time, perhaps because a friend of yours migrated. You hear on the phone, oh, look, life is good in the city. Come and follow me to the city. You know, right now, a lot of the migration to Europe from Africa, I'm convinced, is because people who have gone before, not that their life is better, but they don't want to admit to the fact that life is difficult in Europe. So they call their friends at home and say, it's great here, I have a job, I'm new clothes, everything, and now I'm doing much better than I was when I was living in the village. So some of this is about perceptions too. Do you perceive that the opportunities are greater in the destination area, or do you perceive that they might be difficult? Migration is selective. That means that some people migrate more often than others. If you're very old or very young, a child, or maybe if you're female versus male, your propensity or your likelihood of migrating will be different. So these are versus the young age groups like your age groups. I'm sure many of you came from other parts of Czech Republic to come to Brno. Raise your hand if you came from another rural area to come to Brno. Okay, so we have some idea that people are migrating from rural areas, even here in the Czech Republic. And many of you are young, so you're a perfect example of the type of demographic characteristics of the migrant population. And then often economic motives dominate. So that means either you're looking for a job or you're looking for the education that will get you a better job, that will get you higher income. Many of you are in university for that reason. There are three dimensions of migration. There is a space dimension, so how far people move, local, farther away, international. There's a temporal dimension. That means you could go just for every school year, you could go during the season of the school year to the school and then come back to your home village. Or maybe because you're working on the farm, you go to the city during the dry season, the time when nobody's cultivating, and then you go back. But there's also a long-term migration, which means you simply leave and never return. You just don't go back. And that's what we call permanent migration. And then there is volition. Volition means the degree to which you have the ability to choose. Mm-hmm. Some people have a full freedom. I am benefit. I grew up in a country where basically I have the opportunity to move many parts of the world. I can get a visa. I don't have trouble finding work. But other people have far fewer choices, so their level of volition is lower. One thing that's very important to realize in this field is that migration data are very difficult to obtain. Many censuses will measure 5 years before where you lived. But that doesn't tell you necessarily the full story. If you moved 6 years before the census, you're not counted as a migrant. Okay? And that's what we call migration stock data. That's data about a location and the number of people who move to that location. Some people also try to get migration flow data, the amount of flow over a period of time. But to collect that is very difficult. I have colleagues at the International Organization for Migration, and they tell me that they post people at the border of certain countries in Africa. And they can actually go on a bus and ask people one by one, where are you going? Where are you coming from? How long do you plan to stay? And it's just for information gathering. But that takes a lot of resources. You can imagine getting on every bus, crossing every border of a country is not easy. So there are different mobility types. This is what makes it also somewhat complicated. You have the internal versus international. You have short-term, circular migration, seasonal versus permanent migration. You have short versus long distance. You have rural-urban versus rural-rural, or even urban to rural, which is happening in some parts of the world. People are moving back to the villages. Not to mention trade, okay, pastoralism, people herding animals, tourism. All these are forms of mobility, and they have different durations and implications. But for the topic today, what is most important is to think about the degree of volition, the degree of voluntariness of the migration. So on the left-hand side, you could talk about people who are essentially refugees. They, like the people, some of them in the little video we saw, they may have less volition. They have to leave their village because of a major flood or a drought. And so we would call that more forced migration. On the right-hand side, we would have something like migration, fully migrant, free will situations where someone chooses where they're going to move, and they make that decision and they move, and it's entirely in their control. And then in the middle, you have these sort of middle ground areas where there's some level of volition and some level of constraint. So we can think about, why do environmental factors affect migration, or how might they influence migration? So on the one hand, you have these environmental hazards. These are things like sea level rise, or floods, major storms, droughts, etc. And they occur in the context of a society with different levels of societal vulnerability. So within the same city of Brno, you have some people who are very wealthy and some people who are not so wealthy. And the level of education and other things may vary, which may affect their level of vulnerability, the degree to which they may be harmed by the event. So these are different factors. Could be gender. Some cultures have different clothing styles. So if you're a woman in Bangladesh or Saudi Arabia and you have a flood and you're wearing a chador, it may not be so easy to get out of the flood. You can think about a lot of different kinds of characteristics that make it more difficult to deal with environmental risks. So you have the risk, and then you have the potential for population mobility, whether it's a short-term displacement, people will have to leave the flood zone, and then later when the flood returns, they can go back to their homes, or you can think about longer-term migration. And in between those things, you have other factors that influence. So these are some of the obstacles I talked about, or some of the intervening variables that affect the level of migration. So does the government have a capacity to respond to the disaster? Are they providing flood relief? Are they providing an early warning system? Do people understand that migration could be a way to manage their risk, the degree to which they'll be harmed? Is there an availability of other type of responses? Could you choose to cultivate in a different location or adapt in a different way other than migrating? And what is the perception and experience of environmental hardship? Do you have a past recollection of this kind of event occurring before? And then these have feedbacks, and they affect later the social vulnerability of the population as well. In fact, migrant populations in many parts of the world are the most vulnerable. The people who move from the rural areas to the urban areas are often the people who are most affected by major events like floods and things. So we can think in a very general way of different types of climate impacts, from the short-term flood or drought to heat waves, things of this sort, to things like water availability changing over time because of increased desiccation, water availability becoming less. I'll talk more about this in a little bit. And regional variations in sea level rise, the degree to which storm surge is affecting populations. You can have saltwater appear in your water table. And these are ranging roughly from what we call rapid onset events. They come very quickly, you can't anticipate them, they happen all of a sudden, to what we call slow onset events, which means they evolve over a period of time. And we might talk about the migration response at least in terms of longer term or more permanent migration, being low certainty in the event of a fast onset event, a flood or something of that sort, but higher certainty in the event of a slow onset event. Because in those cases of sea level rise where the coastline is literally changing, people are forced to move and they cannot stay. So this was a diagram, and I don't want to go into the diagram too much because it's very complicated, but what I'll say here is that basically this was produced by a report that I helped, was one of the contributors to this report. It was called the Foresight Report on Environmental Change and Migration. And what you see is that basically environmental drivers can essentially affect all the other drivers of migration. So you have political drivers, so sometimes people are disadvantaged politically and they leave a country. They become what we call political refugees. You know, they're seeking asylum in other countries. You have demographic factors such as population size and density and other things that cause people to move. You have especially economic factors that cause people to move, such as income and wage differentials. And then you have social factors such as family obligations, the need to reconnect. You have people joining family members in the destination areas. All of these factors can be affected by environmental factors. Each one of them may be affected by environmental factors. But environmental factors can also be, in their own right, drivers of migration. So this is kind of the factors driving migration, and then a decision whether to basically stay or migrate. Do you stay or do you go? If you remember that rock and roll song from the 1960s. And these are all affected by the kinds of factors that I mentioned earlier, household factors, and all the obstacles that I talked about before. So one other thing to think about is this sort of stylized, a very generalized graph, which even Robert may not agree with it, but we can talk about that later, Robert. But the idea is that with different levels of income on the x-axis, there are different levels potentially of migration propensity or likelihood of migrating. So at the very low end of the income spectrum, you have what we call trapped populations. These are populations that can't move because they don't have the income. They're very, very poor. So if you don't have the resources, you can't afford the bus fare, you don't know anyone in the city, there's no way to go, so you're essentially trapped in place. These are often the elderly, old people in some kinds of rural areas. On the other hand, if you're very wealthy and you have land and you have resources in the destination, in the area that you're living in the source area, you don't have any incentive to move because you can manage to get through whatever problems occur because of the climate or because of the environment. You also have investments in land. You may have people paying you rents for land that you're renting out. So again, your migration propensity will decrease. In the middle here, you see more propensity or likelihood of migrating in that kind of middle income group. But one thing that may happen is that with growing levels of environmental stress or impacts, we may see more distress migration. You may see more people leaving with nothing but, what we say in English in America, we say, you leave with nothing but the shirt on your back. You leave your house, you leave your home, you leave everything, and you just go to the city and see how well you can make it. Let's do a reality check here. Is everyone following me okay? It's okay, my English is understandable. Trying to make it easy. I may skip some slides in the interest of, if we have to slow it down, that's fine. I have no problem. So nowadays, what we've seen is mass migration has captured the public imagination. I think in Europe, as much as in North America, everywhere people are worried about the boat people coming from across the Mediterranean. We worry about the people coming from Central America and Mexico. I don't personally, but I'm saying in America, we worry about this kind of migration. People are very concerned. They think we're going to be overrun by many, many people. And so you see this kind of reporting going on, people leaving in boats. It's always pictures of people leaving in distress. Some of these reports, the last one, for instance, climate change We hear more politics and politicians saying, we've got a problem and we need to put up greater barriers, we need to control this problem. It's also creeping into the art world. So I went a few years ago, this is now 2016, but to the Museum of Modern Art in New York City, and they had some art exhibits that I thought were very interesting. These are actually a series of videos. In the videos, they didn't show the people, but the people were just drawing on a map their journey from Afghanistan or from Africa, the Horn of Africa, or wherever to Europe, how they got to Europe. And I found it very compelling, very interesting. So you can see some of the dialogue. We came to the Mediterranean Sea, of course. I take a train, I arrive in London. At Brno, I spent 4 days looking for work without finding anything. So you get this kind of discussion about what we call fragmented journeys. Often these trips took 2, 3, 4 years to complete because they would end up in Libya. They have to work some more because they ran out of money. They're paying smugglers all their money. It's a very challenging situation. And then, of course, a month later, 2 months later, I go to the MoMA again, and I see another exhibit, this one on the global refugee crisis. They even had a tent for the UNHCR. They had pictures of people in boats. They had this big map showing kind of links between countries, but also sort of barbed wire where there's barriers to people migrating. You must think that I'm a big patron of the arts, which I am. I live in New York City, so I love going to the museums. So we have all this discourse. We have the media, we have arts, we have everyone telling us that we have a crisis. What is the evidence that actually climate change is driving migration? Do we have evidence? Is it in fact just someone's imagination that this is happening? So there's basically 4 types of past evidence for the impact of climate change on migration. One is if you go back into prehistoric times, you can reconstruct the climate in the past, and you have already the evidence from the written and oral histories or other things to show that people moved. From Mongolia, for instance, they moved to Europe, right? Some people came across Central Europe, and the Mongolian invasion occurred, okay? Other studies look back to maybe in the 1930s, 1970s, 1980s. They may not have very strong data on migration, but they know an event occurred and they can reconstruct, they know what the climate was because we have enough data in the historic period to reconstruct the climate. More recently, what's become very common is these careful statistical analyses. These analyses basically look at the data from climate and from migration, and they put them together, and I'll show you some examples in a second. And then we have extreme events, evidence from displacement from extreme events and climate deviations prior to major migration events in the recent period. So let's look at some of these pieces of evidence. This is an example of some work piecing together the climate using paleoclimatic records. So you can look at tree rings. Robert was pointing out on our trip into the Czech woods that there were trees that were around since, who was it? Good King Wenceslas.
Yeah.
So many years, right? And you can count the number of rings on the trees. And then the wider the rings are apart, the wetter the year, the smaller the shorter the distance between the tree rings, the drier the year. And then you can go back in time and reconstruct the climate history. You can even see when there are fires and other events in the forest. People are using ice cores, they're using sedimentation, they're using all kinds of data to basically produce this long-term history of climate. Okay? So at the same time, people are digging into the ground and they're digging out fossil records showing archaeological sites where people lived, migrations from one place to another. Oh, this pottery type never was here before. This pottery type comes from somewhere else. And they're piecing together movements of populations over time. So we know, for instance, during the medieval, there was a dry period. It was actually called the Roman dry period. It was even called the Great Migration period. And there was a period around 500 or 600 AD when there were major droughts and people were moving around the Roman Empire like mad. It was just before the collapse of the Roman Empire. So there was this kind of thing going on. I wrote at one point that in one of my pieces, I wrote that in Mongolia, the Mongolian hordes, the horsemen that came across the plains, were there because it was so dry in Mongolia that they had to leave. Turns out that it was actually the opposite. So I wrote that, and I felt very badly because later I came across evidence to show I actually had some evidence already. I thought the evidence was good, but it was one of those things you find on the web, right? You don't know if it's true or not. So I had a citation, but it wasn't an accurate citation. So later I consulted some colleagues, and they said actually because of a wet period in Mongolia, the Mongolian population grew much stronger, their horses were stronger, they had more wealth, and then they went farther west. They started going into Europe, and that was when the Mongolian invasion occurred. I think the lesson or the moral of my story is that sometimes it's drought that causes people to move, and sometimes it's abundance. People are suddenly well off and they can move. So that's what makes migration so very complicated, is that sometimes people move because they're well off, and sometimes it's because they're forced out of their home area. This is more recent history, and so this is just a couple examples, but for instance, we had something called the Dust Bowl in America. Has anyone heard of the Dust Bowl? Okay. If you haven't heard of the Dust Bowl, it was appeared in the 1930s, during 20s and 30s, when it got very dry in areas of Texas, Oklahoma, and there had already been a period where we were planting crops and doing all this stuff in an area that historically had been like this weather-wise. And so the weather was, during the time they were planting all the crops and everything, it was very wet. It was good times, they were getting a lot of harvest, but they weren't doing proper land management. So the land dried up during the drought period, and then suddenly you had these winds come, and they call it the Dust Bowl because the wind would bring the dust. The dust was so thick that during midday people couldn't see more than about 10 meters ahead of them. It was so thick that at some point it reached Washington, D.C. All the way from the Midwest. The wind blew the dust. People could see all this good soil in the air. And that was the point where we actually created the Soil Conservation Service of the U.S., and we decided we would do something to conserve our soils because we realized this kind of mistake could happen again. So many people left Oklahoma, Texas, and they moved to California and other places, and they became migrants. I lived in Africa, in West Africa, in Mauritania. Does anyone know where Mauritania is? Thank you. So Mauritania is just south of Morocco, just north of Senegal, on the west coast of Africa. And I lived there in the 1980s. I was doing agriculture, and when I came, it was at the peak of the second major drought. And there were dead animals everywhere. Animals on the ground, everything was dry as can be. I remember the first rainstorm we got blew all this dust, just like the Dust Bowl, all the way from the south. And I saw these clouds of dust that looked like a wall of sand or dust coming from the south. And then thankfully the rains came and it got better. So there were a lot of people during that period that moved to the cities in the Sahel region. The Sahel is that area just south of the Sahara. It goes from roughly like Chad all the way to Senegal. And so they would move to the cities, and a lot of people ended up being pushed out of the rural areas. I talked a bit about these statistical analyses. These are very statistically, quantitative statistical analyses where you have good data on migration. So these are the kind of data I talked about earlier. Where were you 5 years before? Where were you before you moved here? 5 years ago. And data on climate. So they looked at two things: average temperature, average precipitation, and then the number of months where the temperature was above 2 standard deviations from the normal. So these are some statistical analyses. And what you see, it's all over the map. They don't have any consistent signal when you look at the different countries. So in the case of Argentina and Uruguay, this is a case where if it's above average temperatures, way hotter than normal for several months, then the migration goes up a little bit. See, the 2 stars means that that's a significant, statistically significant finding. But other countries, if the temperature goes up, migration doesn't really change very much. It's not a significant finding. So temperature is more important often than rainfall. And for that, we probably expect that maybe it has some impact on crop production or things like that. So this is an example of the statistical approach. This is also a statistical approach. So it looks, for instance, at rural or urban migration, and it looks at the number of drought months over a period of time. And this is the increased probability of migrating. So this is the migration probability, and it goes up the more drought, just as you would expect. But interestingly, the number of hot months, at first it goes down, and then it goes back up again. So for whatever reason in this region of the world, if it gets a little hotter and there's more days that are, more months that are hot, it declines at first, then it gets to a point where people leave, maybe because the impacts on agriculture are so bad. Recently, there's been an increased focus on displacement. This is short term, when people just leave for a short period. And there's an interest in weather and related events, climate events basically, driving displacement. So what you see is that over time, the number of people who leave because of climate events far outnumber the number of people who displace because of, say, earthquakes or volcanoes. Many more people. And there's no obvious trend here, so it's hard to say that it's actually getting a lot worse. But the general consensus is that we're likely to see more people displaced because of this sort of thing in the future. So I have colleagues at Columbia University who have been looking at this question. They looked at this issue of drought in Syria prior to the civil war. Now, there are many people who fled Syria. We all know that. The question is, did in fact climate events, did drought or climate events actually affect the degree to which people migrated and left Syria? They argued that yes. In fact, there was a drought that had never been seen before. You can see here the mean precipitation and the temperatures. So the temperatures were much higher than normal. And the degree of precipitation was much lower, right up to about 2007, 2008. And you see here 2001 to 2007, and over the long haul. And basically, the rainfall change was significant. This brown area describes areas that were significantly impacted by drought. They were very careful. They didn't say that drought caused everyone to leave Syria. That's not the point. The point is, did drought actually provide an additional factor or effect on the decision that people made to leave? There's a lot of debate about this. In fact, when they wrote this, immediately some other people wrote back saying, that's completely not true, you shouldn't say that, and they gave other reasons and evidence for why that's not true. My belief is that, in fact, the drought did play a role. What we do know is that the government of Assad, here we talk about politics, driving migration, government of Assad did not care and did not respond to the crisis that was occurring in the agricultural sector. He did not change the policies, he did not help the farmers. Many of those farmers joined the resistance against Assad and actually became armed members of the militias. So yes, I would say that drought probably played some role. I don't think we can debate that too much. But let's discuss it if there's other beliefs out there. So here's some conclusions that we can draw from the evidence. One is that researchers agree that environmental change in the past has contributed to population movements and will likely do so in the future. And then the Foresight Migration Report also came to some conclusions. This is this big UK-funded effort that I mentioned earlier. And they say that migration is usually undertaken to ensure income in adverse environmental conditions. Rural to urban migration has increased over time in some countries because of environmental change. Environmental change can influence future population displacement and migration. And where people have reduced options to migrate, they are likely to be trapped in vulnerable locations. This is this notion of the trapped populations I talked about earlier. I think this is no longer working. Or some other finding is that the majority of migration will be internal. So instead of this picture of people pouring across the borders and coming across the Mediterranean, we will see more people moving internally within countries. And when you do see refugee flows, it will be much like the past. This is a map of refugee populations around the world. What do we notice about the map? Where are the biggest refugee populations? Refugees per population. We see some countries in the north with high percentages of refugees, but basically the vast majority of refugees are in the global south. They're not in the north. They're typically in the south. We also know that temperature and precipitation can both drive or explain migration patterns, but their effects vary a lot from place to place. So basically, where temperature increases may affect certain populations in one country or one area, it will differ in some other area. It may not affect them as much. That underscores the fact that there are many other factors driving migration. And then there will be some need for planned relocation and resettlement. So this is the report that we did, or a paper we wrote for Science magazine, and it talked about the need to do resettlement, or begin to think about how do we resettle, how do we relocate populations where there's potential harm. So if people are going to move, how many will move and by what time, or by when and by what, to what locations? And this is really what I call the numbers game. And there's been a lot of efforts out there to develop numbers of the number of migrants in the future. Some people, Norman Myers, a famous early quote, he basically said, I think there'll be 50 million people by 2050. I actually think that number is too low, but we could debate that. Some people said 50 million by 2010. And then some conservative group came along in the Wall Street Journal in America and said, show me the 50 million. When 2010 came, show me where the 50 million are. And so they immediately took that data off their website, the UNFCCC. But I think there could be 50 million people globally who have been impacted to a degree by climate factors that may in fact be already migrants from what we call climate factors. And then there's a lot of other ones here that have been revised and updated, and quite a number that we could cite. But the fact is that many of these, we don't know where the numbers came from. So one easy way, this is not working, one easy way to try to come up with some quick estimates of how many people may be displaced is to look at something like sea level rise. And you say, how many people will be displaced if the sea level rises by 1 meter? How many by 2 meters? So this is an example of the Mekong Delta in Southeast Asia, between Vietnam, Cambodia, parts of Laos. And basically what we see is that the climate, sea level rise of 1 meter might drive about 23 million people to be, or it might cause 23 million people to actually move if it's a regular fact, 1 meter average sea level rise. And there may be a loss of 1.5 million hectares of cropland. This is one of we call it the rice bowl of East Asia. So this is one of the most productive lands in the whole world, and they produce some of the most rice anywhere. So there could be very major migration from there. The Nile Delta, a little closer to home, could see quite a number of migrants if the sea level rises by 1 meter. 1 meter is within the realm of, it could be within the century, 80 years from now, we could see a 1 meter or more sea level rise, depending on how things evolve. So these dark blue areas are the areas that are maybe inundated by 1 meter sea level rise. You could also look at things like changes in water availability. So these brown areas are areas that are potentially including much of the Mediterranean basin. So Robert was even talking about drying in the Czech Republic over the last few years. So I think parts of Czech Republic are in this band here of areas that may be affected by significant drying in the future. And if you just total the number of people living in these areas where water availability will decrease by about 50%, you've got about, 405 million people with water availability declining more than 20%. So these could be areas you could say that are at risk of potential migration or at risk of potential changes in at least agriculture and other things if they're not going to migrate. One of the things that people look at is the loss of livelihoods in rural areas. So because of the breakdown in ecosystem-dependent livelihoods, these are people who really live off rainfall. They don't have irrigation, they may have crops, they may have animals they're tending, and they don't have any access to modern technologies. How might those people be affected? So we expect that there will be a lot more people potentially migrating unless they're assisted to build climate-resilient livelihoods. This diagram just describes the frequency on the y-axis, the frequency of major events like droughts, heat waves, other things. And this on the x is the intensity, where a really bad drought would be catastrophic. And if they happen very often, you get into this red zone where you have risks that become impossible to manage. The example here is basically a decline in rice yields. For every 10% decline in rice yields for every 1 degree added in temperature might cause people at a certain point to say, I can no longer farm in this area, and so I may need to leave and go somewhere else. This is an example of some projected water availability in Central America and Mexico. And in some areas you see declines of 25 to 50%. In other areas, up to 20% decline in water availability. This was work we did with the Each4 project, Robert. This is the report I mentioned. So for the future, and I'm going to try to go through this last part very quickly so Robert has a chance to say some words about smart migration. I'm just going to describe some work we did actually with the World Bank and colleagues at a university in New York called City University of New York. And this was work funded and released last year called Groundswell. You saw the video at the beginning. The video is based on the work we did. But I had nothing to do with the video. So I take no credit for the video. So one thing to remember is that prediction is really, really difficult. It's hard to predict things, especially when it concerns the future. It's a joke. But the point is that we often want a crystal ball to be able to see what the future holds, and we will never have a perfect understanding of what the future will be, especially with something as complicated as migration. What I do want to say, though, is in modeling migration in the future, one advantage we have is that we actually have some idea of what might unfold. And it begins to give us some ideas for planning. So Eisenhower, our famous general in America, said the plan is nothing, but the planning is nothing, but the plan is nothing, but planning is everything. So in other words, we need to plan. The action of planning is something that we need to do no matter what, even if the plan itself has to be thrown into the waste paper basket. So our focus in this work was to look at internal or long-term changes in the climate, so changes in water availability and changes in crop production and sea level rise, but we did not look at things like flood, drought, those kinds of things, except when droughts happen many years in a row. That would be what we call a long-term change in water availability. We looked at longer-term migration, not short-term displacement. So we were not interested in people leaving quickly and then coming back to the area they lived in. And we looked at internal migration. So every country we modeled, we did country by country. We did not look at transboundary migration. We focused on 3 different major regions. All of Latin America, we did all of sub-Saharan Africa, and we did all of South Asia. But in the end of the day, we really focused on 3 subregions. That was Mexico and Central America, East Africa, and South Asia. I'm not going to go into the details of the migration modeling approach, so I'm going to skip some slides here. What I'll try to do is summarize the important part for you. So I'll describe it verbally. You can kind of ignore what's up here. But what we used is a model called a gravity model. What a gravity model does is what I described earlier. Remember I had those 2 circles with the intervening obstacles between them? And you have the source area and the destination area. What a gravity model does is basically says in the destination area, you have certain attractive factors, things like education, jobs, healthcare. Maybe you have family members. You have a network of people there. Whatever it is attracting you, those things serve as like gravity to pull you. A gravity model also says that a larger urban area will tend to exert a greater influence. Like New York City has a greater influence on its area, on much of the United States, than does Brno does in Czechoslovakia, okay? Czech Republic, sorry. So what the gravity model basically does is model this pattern we've seen throughout all of human history of people tending to move towards urban, more built-up areas. And it's able to replicate that. The model can actually go back in time and show you that certain things have changed over time. So this group in Colorado developed a gravity model for the future out to 2100. And they used something called the shared socioeconomic pathways. The shared socioeconomic pathways are basically these models, the ideas of the future, different scenarios describing possible futures in terms of income, in terms of population growth, in terms of education levels, etc. And each of these, they go from SSP1 to SSP5, represents a different possible future. And so they modeled the world's future population distribution based on these different scenarios, the shared socioeconomic pathways. They did it for all 232 countries. They had it by urban and rural population for every, it was done on a grid cell, so we have these square cells. Each cell is about 15 kilometers on one side at the equator, 7.5 arc minutes. So each cell is modeled into the future, and it's a 10-year time step. So every 10 years you do it again, and it shows how the population moves from maybe more rural areas to other areas. But the early work doesn't include any climate assumptions. So one of the things I said to my friend Brian, who developed this model, I said, Brian, do you think that it's really realistic to be moving people into the coastland? Or do you think it's realistic to move people into these areas that we know are going to become much drier in the future? Is that true? Do you think it's possible? And he said, I've been thinking about that myself. So it was fortunate because at that time I was going to the World Bank for a presentation and I mentioned this idea. And they said, I think we need this for our big report. We're coming up, we have to do a big report on migration. And instead of going blah, 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 migration this, migration that, they wanted some numbers. They wanted to show what might happen in the future. So I took this idea to the bank and I said, how about if we add climate impacts? And the impacts will make places either more attractive or less attractive. So people will either be more likely to go into the area or they'll be less likely. In fact, they'll be pushed away from the area. Think about push and pull. And so we did that. You don't have to read this, too much text. But the point is that we tried to do this in a scientifically robust way. It's not a perfect model. A perfect model would actually take into account your personal preferences and your personal preferences and your personal preferences and understand what every personal decision is. This is what we might call an agent-based model. But an agent-based model requires so much data to calibrate and requires so much effort to understand what people's, at what point will you decide to migrate? When the drought gets to be 20% worse or 30% or 50%, and so you need all that information from the past in order to project into the future. This is a very much simpler way of doing it, but it also has a lot of assumptions underneath it. It's not perfect, but it does a nice job in some ways. So what we did was we had applied this existing model, and then we projected with the climate impacts. This is how the model basically works. So look at these cones. The cones go over a certain area, and each grid cell is basically has what we call a population potential. That's the degree to which it attracts population in the next time step. So every time step is a decade, and from one decade to the next, you calculate the population potential for every grid cell, and then you come up with a new population distribution in the next time step. Remember, you also have to add people, because populations aren't remaining the same. They're growing. In most countries of the world, they tend to be growing. So let's see if I've covered all the assumptions. Yeah, basically. So what we did is we combined these existing scenarios of future population projections with some that included climate impacts. So these are combinations of, on the left-hand side, what we call the pessimistic reference scenario. It's a combination of a shared socioeconomic pathway, SSP. Let me just see if it shows me. Oops, I'm sorry. So the pessimistic scenario is RCP 8.5, high emissions, and basically very bad development prospects. In the more inclusive development scenario, we have high emissions but better development prospects. And under the more climate-friendly scenario, we have low emissions but bad development prospects. And so these were the three scenarios that we had. And basically, we used the pessimistic, the bad development, and the bad climate to frame everything. And we compare everything to the reference scenario. We also had, for each scenario, we had 4 different model runs. And these combined different models from something called the CIESIN project. This is the Intersectoral Impacts Model Intercomparison Project. Say that 10 times fast. It's a very elaborate multinational effort run out of the Potsdam Institute for Climate Impacts Research. And basically, they had models of future crop production. They had models of future water availability. They also have models of future net primary productivity or ecosystem productivity, of health impacts, forest impacts, you name it. They have a lot of different models. But we chose these 2 different types, crops and water, and we combined them in different ways. So we had different gridded global population models, or I'm sorry, global climate models, GCMs, and we had different impact models, and we combine them in 4 different ways. These maps are just to show you for different regions of the world what some of the projected trends are, say, in water availability. So where it's dark blue, that means that water availability may increase by up to a factor of 2, a double or more, okay? That means effectively for many dryland areas, it may not be that significant. It looks like a very wet scenario where things are going to get very, very wet in the future because of the map. But basically, the dark blue areas, in many of those areas, it's dry. So you might see, instead of 100 millimeters a year, a rainfall a year, maybe in the future you'll see 200 millimeters of rainfall. To give you a benchmark, in Africa, for instance, it takes about a minimum of about 500 millimeters of rain to grow a crop. So even if you see a doubling in some of these areas, it won't be significant from a livelihood perspective. The red areas in the dark red are, maybe I'll show you another region. In, say, Mexico, parts of Mexico, they could see a decline of, say, 70 to 80% in water availability in some areas. So the darkest red is actually a 100% reduction in water availability. But I think most of the areas in Central America. And you can see in some of these high emission scenarios in the bottom panel, 8.5, RCP 8.5, very red and very dry. And so South Asia looks generally pretty wet by comparison with the past, but Afghanistan will dry. And then crop production is a bit more of a mixed picture. you can see some areas of getting more crop production and some areas where it's getting worse, red. Let's keep moving. Sea level rise we had to take into account, so you can imagine a place like Bangladesh, that's a very important factor. So the red areas in Bangladesh are areas that are be inundated. We combine these in a model. I won't go into this model because I think it would take too much time, and I don't want to bore you too much. The point is that there's math that goes into this, and we could include in this equation that they use for the gravity model, we could include local characteristics such as the degree of crop production and water availability or things like that that would affect the degree to which people would move into a grid cell. And we did this by actually calibrating historically. So we had data on population distribution in the past, and we looked at the changes in that population distribution in the past. In an ideal world, what you would see is changes that meet this, that look like this line with the squares in it, the projected population, where urban areas would have very high population and rural areas would have very low population. But what you see is that in the real world, that isn't always the case. So we wanted to determine whether climate factors could predict the difference, help essentially account for the error that the model, that the actual empirical data produced. So we looked at the historical climate impacts, and we looked at the change in population distribution. And indeed, the climate impacts did in fact explain some of these deviations. So it was based on these coefficients that we were able to model the future population distribution with climate impacts. Then what we did is we compared the versions of the model without climate impacts with those that have climate impacts. And when we see a difference in the population in a grid cell, we attribute that to migration, because that's the fastest demographic variable. We assume that births and death rates will not be affected significantly, but rather that it's migration that's causing people to move out of an area. So that's basically, this is too much text. I apologize for that. It's maybe easier to see here. These are the differences for the pessimistic scenario in Ethiopia. We have 4 model runs where it's red. That means there's more people moving into an area, okay, than because of climate factors. Where it's blue, there's people moving out. So what we saw was in Ethiopia, people were moving out of the northern highland area, which is mountainous, where there's very high population densities, and moving towards the south and southeast, what we call the southern edge of the Rift Valley. So this is an arc that basically goes from here to here. So by averaging the 4 model runs, we could come up with one scenario, essentially, showing the change in population. I want to be very clear. Everywhere in Ethiopia will grow in the future. The population is growing. It's going to double between now and 2050. It is going to go from about 90 million people to about 180 million people by 2050. Think about that. That's not happening in the Czech Republic, right? I don't think so.
Definitely not.
Everywhere is going to grow. What this tells you is basically the change in population that might occur as a result of climate impacts, in addition to whatever other changes may occur. So this is essentially the delta or the change due to climate impacts. All right? It's a little bit complicated to say in English, but it is the number of people that would be there that would, or the number of migrants that are coming into an area owing only to the climate impacts, not to other factors. Every area is likely to grow some. All right. And then we did this total. We totaled all those grid cells, all the positive grid cells, because if you take the negative and the positive, they net to 0. You just take all the positive grid cells, you sum up the positive grid cells in all these regions, and you get 140 million people. That was the headline number and we also got a range. So the range here is due to the 4 model runs I mentioned earlier. Each of these scenarios has 4 model runs. One of the things you see is that under all the pessimistic scenarios, the number of migrants is always higher. We did not change the model in any way. This was purely came out of the model. The impacts, the greater impacts, the more migration you see. The other thing that you see is that in Africa, you see much more sensitivity to climate factors. So it tends to be more sensitive, and you see more movement as a result of climate impacts. Latin America had the lowest sensitivity and also the lowest numbers. Okay, these are some maps that show hotspots, and I'm about to wrap up. So Robert's probably wondering when I'm going to stop. So hotspots in red, those are areas that we'll see in migration. This is across the 3 different scenarios. We simply overlaid the 3 scenarios and took the top 5th percentile of each one, scenario and said, where are the greatest number of new climate migrants? And in this case, the highlands of Mexico and the highlands of Africa tend to have more migration in, except for parts of Rwanda, Burundi. And then some of the lowland areas tend to see more out migration in blue. We could also look at livelihood systems and look at the change in number of people in different livelihood systems owing to migration. In general, what you saw is people moving out of rain-fed areas, maybe into urban areas, and also into, to some degree, pastoral areas if the rainfall changes are significant enough. And urbanization is an interesting factor. If you take the EU definition of urban, which is 300 persons per square kilometer, it actually looks like most of East Africa becomes an urban area, which of course is not really what will happen, but what we'll see is that basically there'll be more dense settlement in these areas because the population levels will be so high. There are a lot of challenges with this type of migration. I won't go into the pros and cons. I think what I'll do now is I'll close. I will just say that some people have said, oh, this is very deterministic. You're making climate a deterministic thing. It means that people move because of climate, and that's the only reason. I think we're very careful to say that people move for all kinds of reasons. That's not what we're modeling. But what we're trying to do is see what's the incremental difference owing to climate factors that may drive people to move, and that was what we're trying to do. There are many other factors that are important to migration, political factors, economic factors, cultural factors, etc., that drive people to migrate, and we acknowledge that fully. I do have questions, but we can come back to those questions at the end. I think what I'd like to do is pass the microphone to Robert and give him the opportunity to present.
Okay. Thank you so much, Alex, for an excellent presentation. So I would like to just introduce very shortly our case study dealing with the Maldives and climate change impacts on the migration patterns there. However, at the beginning, I would like to mention that this is a little bit opposite case study that we just found that not every modeling is working in a reality. That's a first, and second, that I hope that the next Groundswell report could be published here in case the technological agency will support our new proposal, which were already submitted just a few hours ago. No, I'm joking, of course. That's you did a so good and excellent job dealing with the Groundswell report. So come to our case study. So just short introduction to the Maldives. Maldives is a low-lying island country. This is the archipelago, or more than, or almost 1,200 islands, coral islands, with about 300,000 population. What's the most important information from the slide is the last one. So the local Sagarmatha is about 2.5 meters. Yeah. So you can recognize very easily that one of the main climate change negative impact is sea level rise. Yeah. That's the picture of Male, the capital, and the island with the same name. And behind the Male you can find here the new artificial island with the airport, which continues on the left side with a completely new islands. So Maldives economy is deeply dependent on the tourism sector. so which produce more than 30% of the GDP. The fishing, which was in past like a main income source for the local population, is on the second level now, and it's the influence and the impact of the fishing for economy is dropping. So Maldives are affected by nature hazards like a sea level rise and also environmental risks like a drink water access and coastal erosion. Just another number that 80% of the population is living below 1 meter above the sea, and according to IPCC reports, the Maldives will be flooded to the level of 90 centimeters to the end of this century. However, it depends on the scenario, so I count with this middle scenario. Okay. Maldives, the local population completely lost the access to the original sources of water, drinking water, and that's interesting from the anthropological point of view, they completely lost the ability to receive water, drinking water from the rainy. Yeah, so this like a tradition was completely lost. Anyway, so come to our methodology. So we used a completely different methodology, which was presented here by Alex. So we focus on a small case study. However, we use this longitudinal approach. It means that we did the same surveys with the same people from 1 year to another 4 years, and we would like to continue with this trend because we found a little, not little, I think the major differences between our two surveys. So firstly, in 2013, we used the quantitative questionnaires approach with the ordinary population from the street. We asked almost 350 people about the question dealing with climate change impact, about their perception of the environmental changes, etc. And we also did a semi-structured and in-depth interview with the main stakeholders, such as decision makers from parliament, from ministries, from non-profit organizations, experts from academy and also private sector. So in 2017, we did this qualitative research again, asking almost the same people on the same question, what happened, what was changing during these 4 years. And moreover, we also use these GIS methods, so that's we use the mapping, measuring, and using this here developed mobile application with its name Gisela, which is now in a global market. Our research questions are there. However, I would like to focus just on the first one and the last one. So we were interested in and about the perception, so how people perceive the environmental or climate change. Why we asked about the perception. So, however, the measured data could be different. The most important, according to our previous study in Africa or in South Asia, is how people or decision makers, the main stakeholders or the ordinary population perceive the changes. If they don't perceive the changes, however, we know that there are some changes according to measured data, there is not any action. There is not some mitigation or adaptation measurements. So that's why we use the perception like one of the concepts for our research. And the migration patterns was mentioned like one of the possible adaptation strategy. It was also mentioned by first democratic elected president, Nasheed, which is now living in London in exile, that Maldives will need some money to collect money from a tourist industry for a displacement of world population to India, Sri Lanka, and Australia, because his government believed that this is just only possible strategy how to survive in the future because of the sea level rise. So that's the map of our survey. So we did the survey in the most populated area in Maldives, so in the capital Malé and the close islands, Willingly Island and these Hul Malé and Hule Islands, which are mostly new artificial island. We already published our surveys and the research outputs, not every research output because we have a lot of data, but partly we published in 3 papers. The first one was in Geographic Journal and this year in Climatic Change. I forgot to mention that just abstract of our papers published by team of Alex and our team you can take on this table, so just to see that something about our results. So come to migration patterns. So our respondents from 2013 survey, they more than 50% from the more than 50% they told us that they want to out-migrate from Maldives. Yeah. So, but the reason was a different one. However, the most frequently mentioned reason for out-migration was a better economic condition. Yeah, they want to live in better livelihoods. And the environmental climate reasons for migration was in minority. During our second survey, we found that Maldives are almost prepared for a next future climate impacts, especially on a sea level rise. So we found that the main stakeholders or decision makers completely rejected the opportunity to migrate out from the islands because they want to adapt, they want to stay, they want to be more resilient. And that's why they use desalinization, one of the main adaptation strategy, how can the local population can receive the drinking water. Because the salt water, it's like there is enough sources, how can they receive the drinking water or using water for their existence. The second one was the building of new artificial islands. I will show you the pictures how it's working. There is one huge paradox. However, the material from coral reefs looks like a possible source for building a new island for a surviving of the population. And the construction of new houses with a higher elevation in past was used like a, let's say, a bit good strategy, adaptation strategy, but it's interesting with the impact of China's investment, it stopped. Yeah, I will show you on a picture. So you can see this is mining corals, some small hill, and that's the paradox is that you can't to take this small amount of the, let's say, stone to your luggage, to your home. If anybody will find you on an airport that you will take it, you will be arrested and pay a lot of money. But here, as you can see, it's completely destroyed for the sand. I don't know how many million tons of this for the construction of this new island. So this is the newest island, which were produced by any Chinese companies, and yeah, now it's inhabited. Anyway, this is the houses which were started to build 15 years ago, and you can see that each of the house has elevated floor, so it means that people are living like on the second floor. The first floor is just for equipments, bicycles, etc. But now it's completely changing the strategy because the Chinese companies want to be more effective and wanted to sell more flats to the local population. So they are producing new houses without this elevation. So on this map produced by David, you can see the new parts of the island which were built in 2017. this orange color. So this is Hulmale and Hule Islands. This is the airport, as I already showed you, one of the first picture. This is the already populated area, and this is the new populated area. This is the capital and island Male, and according to locals, about 20 or 25% of the islands is a new, it's a new, like a artificial island, especially from the south and a little bit north industrial areas. Okay, so come to the end. The migration and sea level rise is frequently mentioned in the local discussions, in the local medias. However, no one respondents wanted to go outside because of many reasons, such as traditions, such as religion, such as language, such as the history. They definitely believe that it's possible to stay in the islands, and they be more resilient, and they can adapt. However, they don't believe that will be possible in every Maldives islands. Okay, that's why the Maldives government supported the strategy that people or the local population has to be moved to the selected islands, which will be protected against the sea level rise. So migration from this affected area is not viewed like a possible adaptation strategy. They prefer to adapt in situ. Okay, so according to my point of view and according to our respondents, decision makers, the Maldives is in a, let's say, good way to be adapt against the climate change impact. However, it's interesting that in many publications is Maldives still mentioned, or in the models is mentioned like one of the islands which will be probably displaced because of the sea level rise. So in fact, we will see what is possible, but I think that's interesting that something different is in the reality and something is possible to see on the model. So thank you very much for your attention, and thank you to guys from Department of Informatics to support our study here. Yeah. Thank you.
What I found interesting about Robert's presentation is that indeed, this is a case, a country that's well aware of the risks and has made a major investment in moving people off of distant islands. As I understand it, it's not voluntary. I think there's a requirement that they move to Male or to one of the protected areas. And so you could say that climate migration is happening there as well. It's just a planned relocation into the capital. Now, Maldives, as I understand it, is actually an area of potential uplift. So it's actually, sea level is always relative. So the sea levels are rising because of glacial melt and because of land-based ice masses like in Antarctica and Greenland. But if you factor in local things like the geological factors, some areas of the world are actually rising relative to sea level. And so I think Maldives may be in a better position than some countries because it's actually rising, not subsiding. That is the underlying geology. Robert can correct me if I'm wrong there. I didn't get to my summaries, so I wanted to just make a few points, and then I thought we could open it up to some broader discussion and then have our drinks and refreshments. So my point is that I think that climate is already a factor that's influencing migration. Most climate migration and displacement will be internal, but even the small fraction that may be international will still be potentially a large numbers. So if you consider some of the large coastal zones of the world that may be inundated, or some of the drought factors that may push people to migrate, even a small fraction of total migration could be a large number of people. People migrate for many reasons, with economic factors being the most important. But there may be clearer factors of climate driving low-lying migration from low-lying states, particularly in the South Pacific, if not the Maldives. And climate factors are an additional push factor in many places like drylands and mountain areas. I would just say that this is happening against a backdrop of a lot of other changes that are occurring. Major demographic shifts. So you have this rapid population growth I talked about earlier. You have population pressures on land that are already causing erosion and land degradation in different parts of the world. You have fragmentation of land holdings. You have new private sector land grabs, we call them, where companies are coming into places like Ethiopia and simply buying the land. They call them sovereign land grabs. So countries from like the Gulf nations that have a lot of oil wealth, they'll buy land in another country and then they'll grow their food there as if it's part of their country. It's a new phenomenon. You have the breakdown of institutions in many parts of the world that I was just saying to Robert, you know, parts of the Sahel were pretty safe until 15 years ago, but now you have military groups, you have armed bandits, you have Boko Haram, you have Al-Qaeda and other groups operating in these areas. In the north, you have countries like Hungary, the United States, Britain, that have all elected essentially nationalist governments that want to say no more people, stop, don't come to our country anymore. And then there are global efforts to achieve the Sustainable Development Goals. We haven't even mentioned those. But everybody wants to make the world better, but at the same time you have all these challenges. So it's a very challenging situation. So these are some of the questions I thought we could potentially discuss, but I'm also happy to answer any questions that you may have based on my presentation or observations. The simple question of who is a climate migrant. Can you point to someone who's a climate migrant? I think this is maybe gets at the crux of the problem, because we all know that people move for many motives, for many reasons, and climate may not be the primary motivation. So I'm happy to take any questions, or we can.
I have a question, if I can ask. My question is on empirical framework. So because I'm really surprised, I will be very surprised, how you deal with the endogeneity problems, because the
How
people
you deal with what?
with the endogeneity problems, like impact of the concentration, because the people migrate to similar places. And this migration, this concentration of the people in some specific places, so it increases the wages, it increases economic development and so on. And this effect or this behavior has also impact on the migration itself. So how do you deal with that problem?
Endogeneity is, I think, what you mean. The word.
Yeah, endogeneity.
Yeah, endogeneity. Right. Well, there's feedbacks, and I mentioned that earlier. Right. There was this diagram. You came in a little late, I think, but there's a diagram showing that once you have people migrating, it can actually affect the attractiveness of the new locations, and so. The gravity model specifically doesn't deal with that issue specifically. It just basically seeks to replicate common patterns in the past. If suddenly the world decides that we don't want to agglomerate, we don't want to live in small towns, cities, or large urban areas, and I want to emphasize that a lot of growth in the future will be in these smaller towns and cities. It's not just the mega cities of like Dhaka they described in the movie, in the film, or Mexico City or Sao Paulo or that kind of thing. That in many cases, smaller cities will become more populous in the future. And one big question is what is the role of these small to medium-sized cities in possibly providing an adaptation to climate change? But what the models produce from the past, based on historical experience, we cannot say for sure will happen in the future. This is an obvious issue. And another factor that could be important is that as people move into big or medium-sized cities, many of which are located on rivers with increasing flood risk, on coasts with increasing flood and coastal storm risk, these can cause additional effects on those populations that move. But I'm not sure I answered your question fully, so any other questions? Yes, David.
I'm thinking when you compare the gravity model, are you somehow coping with the changes of, let's say, the thinking of the people, or let's say maybe rather the government? For example, in Czech Republic, some 30 years ago, there's been no substantial discussion about nature conservation, about pollution, and so on. In the last 30 years, maybe, there is a substantial change. We take care about the nature, about the greenhouse gases, and so on. And in maybe last 5 years, we are well aware that we must take care about the soil and the water, and so on. So, for example, in Africa, there are many countries, in my opinion, that are developing slowly, and maybe in 10 years there will be some change in the thinking of the people as well as the government, and maybe they will be forced.
So, yeah, the question, just for the benefit of the recording, is whether the gravity model takes into account perceptions and changes in attitudes, say environmental attitudes. The answer is no, it doesn't. I think probably the bigger factor in many countries will be things like, how will governance systems evolve? Will, in fact, governance end up being more equitable? Will politicians and decision makers start making decisions to improve the quality of life for the population? Or will there be a continuation, in some countries at least, of the kinds of changes in or I would say repetition of bad governance, what we call kleptocracy, government by taking and putting in your own personal pocket. This kind of thing, if that continues, I think there could be a lot of uprisings in many parts of the world that we right now consider to be stable. When I was in Peace Corps in West Africa in the 1980s, I never dreamt that there would be radical Islamist groups. I worked with Muslims. I was among many Muslims. I had a good relationship with everyone I worked with, I hope. I'm a Christian, or I come from a Christian country. No problems. Now, things have changed to the point where this kind of ideological change has actually driven not only people like aid workers and others out of the country, but many people from the country themselves are fleeing across the border into other countries, from Mali into Mauritania, from Niger or from Chad to Niger, and from northern Nigeria into Niger and to other neighboring countries. And all of these things were completely unforeseen. So these were safe regions. They were considered very stable in many ways. They weren't well governed, but they were stable. And what happened is over time, there was a combination of corrupt governments, a disregard for people living like the nomadic people, such as the Tuareg and other groups in the desert areas, complete disregard. We want to just forget about you. And at a certain point, the Tuareg were made in alignment with, for instance, the people of the Islamic Maghreb, the Al-Qaeda, and they joined together. It wasn't because the Tuareg were particularly Islamist or fundamentalist, but they saw political gain from doing that. And in Boko Haram, the northern parts of Nigeria, what I understand is basically the same thing. People in the north had been disenfranchised, the Muslim north was disenfranchised, they had no say in government, and that drove them to rebellion. And Islamic ideology essentially supported or came in after. There was a sense of injustice. So I think the more complicated and long answer to your question is there are so many things that we cannot foresee that this is meant not, again, to be a crystal ball, but to begin to get people to think in each country, hey, what could happen? How could people move from one place to another? And maybe also to account for the fact that with climate, this can be another exacerbating or another factor that makes this situation worse. Any other questions? If not, we can, yeah, Robert.
Thank you again for your excellent presentation. I have one question dealing with your modeling of internal migration. Why you don't use a modeling also the international migration? I agree with you, the majority of the climate migration is on an internal level, and I understand the reason for that, but why not? Because, you know, in Europe now, this is a huge topic. If the climate can produce another waves of massive migration as we experienced, let's say, a couple of years ago.
So we did consider including differential climate impacts between countries or different levels of vulnerability, and looking at that as another factor that could cause an increase in transboundary migration from one country to another. The short answer to your question is we didn't have the time. We just ran out of time. We literally did all the modeling within a 6-month period, and we did everything. Yeah, and the write-up was another 2 months, so it's 8 months total. So we were under extreme pressure. I kept on telling the World Bank, this is really a research project. It's not, we're looking at it as operational, but we actually weren't sure that we would get useful results out of the model even after they funded. And then when we got to doing some of the work, we began to see that the results were indeed somewhat useful. But anyway, the point is that we were under a lot of pressure. There would be a lot of complications to doing exactly what you described. So we do include international migration. All of the SSPs, the shared socioeconomic pathways, they each have their own international migration levels. So that's already included, but we did not include climate as an additional factor driving international migration. So.
Thank you so much, Alex.